One of the most interesting features for a lot of clients is the ability to do vMotion and storage vMotion. And this is one of the things that's really going to change how we operate and how we think about things like maintenance cycles and downtime and so on, because we can actually move virtual machines from one server to another while they continue to run with some performance impact, but relatively minimal actually, or where we can actually move virtual disks from one data store to another. That requires us to have ESX, or in this case now ESXi for the more modern versions, and also some form of shared storage where we've got the virtual machine running between two servers that are connected to some common data stores. And that way we really just have to handle syncing the memory, and it makes things much, much easier to do. We need vCenter in order to support vMotion, but in addition, if we're running the Enterprise edition of vSphere, we can use the distributed resource scheduler to actually, based on all the performance statistics that are collected, make vMotion operations happen for us automatically to dynamically scale the workload across all the members of the cluster. And that just uses a specially designated network interface to specify where we want to actually copy those memory pages and make that synchronization happen. So this is really one of the most interesting features of ESXi, and we'll take a look at it in the videos. The distributed resource scheduler is really going to help us automate the migration of guests based on actual performance utilization, based on demand. And there's a few different ways we can operate this. We can actually use it if we're not totally confident in the ability of vMotion to operate with our virtual machines, or we're concerned about the potential performance impact. We can actually just use the DRS to place virtual machines when we start them, but not to perform those types of scheduled vMotion. So take a look at the vMotion videos and the distributed resource scheduler videos for more information on that. And in addition to that, if one of the hosts running a set of virtual machines fails for whatever reason, or even if the virtual machine itself fails, we want to be able to bring that virtual machine or those virtual machines back online as quickly as possible. So the VMware HA features allow us to monitor hosts and monitor virtual machines running on those hosts. And if there's a failure, to actually get that virtual machine restarted on another host. Now that requires those hosts to be part of an HA cluster. It also requires those virtual machines to be placed on shared storage, but that's going to allow us to pretty easily manage our service level agreement targets and make sure that even in the event of physical host failures, although there will be some downtime, that all of those failures are detected and recovered automatically. And that's going to make a big difference. And our applications and the guest operating systems don't need to be aware of that at all. So we don't need to install a specialized version of the operating system that supports clustering or requires additional licenses or anything like that. Although it does require the right edition of VMware for it. Integration with your network and storage is really going to be critical to separate management traffic, vMotion traffic, fault tolerance traffic, where the same virtual machine is actually run on two hosts simultaneously so that there's no downtime in the event of a failure. Although there are a fair number of architectural restrictions on how to do this. We could potentially have dedicated NICs to use for iSCSI and NFS storage access, as well as the NICs that we're actually going to use to host our guest traffic. So all of those things we're going to have to think about, and we're going to have to determine how we're going to use those physical network interfaces combined with virtual switches, combined with port groups and VM kernel interfaces to separate and or aggregate different types of traffic. So take a look at the network videos for more information on that. When it comes to a storage architecture, we really need to have some form of shared storage, as I was saying, to support things like high availability, the distributed resource scheduler, previously the VMware consolidated backup agents, but now the new vSphere data protection functions like vMotion and storage vMotion are also pretty dependent on this. So typically we're going to be using either fiber channel, iSCSI, or NAS. All of those options have their own usage and their own place. Take a look at the storage videos for more information about some of the benefits and trade-offs between these, or refer to the slide here for a little bit more of those details. But it's important to remember that we can actually mix and match these different storage types, not within the same data store, but to provide different tiers of storage, for example, for virtual machines with different resource requirements or different capacity or performance requirements. And that all requires local SCSI storage, shared iSCSI or shared fiber channel storage to be formatted using the VMware file system. So it's actually a cluster-oriented file system where multiple hosts can actually be reading and writing to the file system at the same time, which is not typically how something like the Windows NTFS file system works, for example. Although they are now moving into things like cluster shared volumes to support Hyper-V clusters and file share clusters. running in much the same way where all the disks are accessed simultaneously. And that's traditionally not something Windows clustering had been doing up until the last couple of versions. So the virtual machines or the guests are going to be stored out on those VMFS partitions. And that's really the only option that we have other than using NFS file shares to store virtual machines on as well. We can do that using these Unix style NFS shares, but we cannot do that using Windows style SMB or CIFS shares. So again, the goal here is to provide a cluster capable file system. All the hosts in the cluster are going to have access to those shared LUNs. So we're going to have to handle provisioning on the SAN in an appropriate way. And then locking actually occurs at the file level rather than at the disk level, the way, for example, Windows clustering has traditionally worked. We need to make sure that we provide a set of disks that have the appropriate level of performance, the appropriate level of bandwidth, the appropriate support for the number of I/O operations per second that we expect. And typically it's going to require us to provision quite a few different LUNs and create multiple data stores to do things like, for example, reduce locking overhead. Depending on whether or not you have storage infrastructure that's VAAI capable, then, for example, thin provisioning can have a much higher locking overhead than using thick provisioning where all data file space is pre-allocated. It's going to be very important to understand the capabilities of your storage infrastructure, and that's going to drive decisions like how many virtual machines you're going to place on a single data store. Definitely, when we start moving into a SAN-oriented environment, especially if you're using Fibre Channel, then as much as possible, we're going to want to leverage the capabilities that SAN already has for things like handling controller failures or handling multipathing and load balancing. And that may even require the installation of special path selection policy modules into ESXi, things like caching and mirroring and snapshots and so on. And all of those things will be particularly useful if your storage infrastructure supports VAAI and has the ability to offload some of those tasks directly onto the storage so that the host actually doesn't need to be involved. And the best way to get maximum value out of this is to combine your storage types based on needs, depending on size, depending on speed, depending on the RAID types, and so on, and try to think about how you're going to leverage all those features and how those features are going to come together to help you protect or optimize the performance of certain types of virtual machines. Maybe they're production critical, maybe they're development, test, or support machines. Typically, Fibre Channel is going to provide us with the best balance of performance for price compared to, say, solid-state disks. Serial attached SCSI is quite good. Serial attached ATA is not really appropriate, and in fact, we really shouldn't be using serial attached ATA on local storage. However, there are quite a few SANs that are providing it for an archival type storage or a low performance capacity type storage environment. You'll definitely want to think about all this. Certainly solid-state disks will provide the best performance, but of course at the highest cost and with much lower levels of capacity than we're used to on magnetic disks. And things like wear leveling and trim support are supported in VMware, but it's going to be very, very important to make sure that your hardware supports it as well. And you're doing everything in line with what your storage vendor recommends for integration with a VMware environment. So we'll take a look at some of those things later on in the videos. There's a lot of things to cover, but that gives us a little bit of an idea as to some of the ideas that we're going to need to be familiar with for how the modern ESXi operates, how it runs directly on the hardware. The guests really see a generic set of hardware that should be widely supported and get vCenter set up and get our environment working. We can definitely make a dynamic, scalable, elastic environment that we can easily add or remove or redeploy capacity for on the fly.